Okay, so today's pretty simple. Today we're going to talk about similar polygons. So, this is something that you probably went over last year in Algebra 1. We've kind of talked about a little bit this year, just a tiny bit, but it's pretty simple today. But it's going to set us up for success tomorrow. So, first thing is similar polygons have the same shape, but not necessarily the same size. Now, we have the symbol for congruent, where you have the equal to sign and then a little squiggly over it. So remember, congruent means measures the same. So if you had congruent figures, they would have the same angle measures, the same side lengths, they would be the same shape, and the same size. Similar polygons are the same shape, but not necessarily the same size. So we have a new symbol, and it's just this squiggly. Okay, so no equal sign, it's just this squiggly. Now, if we know that polygons are similar, there's two really important properties that we're going to work with today. The first thing that we know about similar polygons, that their corresponding angles are congruent. So just like congruent figures, how if this was congruent to this angle A, it's congruent to angle G, B, it works the same for similar polygons. Although one figure is probably bigger than the other, the angle measures are the same. Okay? So if I were to look at these two polygons here, one thing you're going to have to do today is to write what's called a similarity statement. And we've done this a little bit with congruent figures, where if I said that this figure is congruent to this figure, same thing except it's going to have this similar symbol instead of the congruent symbol. So if I wanted to say that this trapezoid is similar to the bigger trapezoid, you're going to start by naming the first trapezoid however you want, for the most part. Okay? You do have to go in order. You could not go from A to C. See the problem there? Okay? You would have to go A, B, right, that way around. So that'd probably be the easiest way to do. So I could say A, B, C, D. Now, it does not matter how you name the first figure, but it does matter how you name the second figure, because the order of the letters tells you this angle, the first letter in the name, that angle is congruent to the angle that comes first in the second name. So, since angle A, you can see, I know yours isn't in color, but since this one's in red, right, and you can kind of see it because the picture looks like it, I would have to start with G. And next, since I did B, I would have to do H, see the one arc, congruent to the one arc, I, and then J. This would be my similarity statement. You're going to have to do that today. So when they ask you for a similarity statement, it's just asking you to name the two figures in the correct order. Okay? Now, this isn't the only similarity statement you could do. If you were to change the order here, it would change the order here, but it should look pretty close. All right? So, since they are similar, and since I named it this way, we know that the corresponding angles are congruent. I know that angle A is congruent to angle G. I know because it's marked on the picture, but I also know because they're the first letters, like we talked about. We have angle B congruent to angle H. We have angle C congruent to angle I. And we have angle D congruent to angle J. So the angles are pretty straightforward. Congruent, they measure the same. You know one, you know the other. Now, the side lengths. We have talked a lot this year, not this semester, but last semester, about congruent figures, where if I knew these two figures were congruent, the sides were the same, because they're the same shape and the same size. That's not the same with similar figures. With similar figures, yes, their angles are congruent, but their sides are what's called proportional. So what that means is, let's say AB measures 2 feet, 2 inches, whatever it is, okay? And let's say GH measures 4. If you were to write the corresponding sides, so this side to this side, as a ratio, so 2/4. And if you were to reduce that, you'd get 1/2. That 1/2 is what's called the scale factor. If the ratio from AB to GH simplifies down 1 to 2. Every other side length, every other set of corresponding side lengths is also going to reduce down to 1 or 2. It's not going to be 1 to 2 necessarily, but maybe like if AD was 3, GJ would have to be 6. Because see how 3 to 6 would reduce down to 1 to 2? Okay? That's what it means that the side lengths are proportional. So what I can do is I can set up what's called an extended proportion. So what that means is I would just write the side lengths as ratios. So I would say, well, AB corresponds with GH. And I don't know what the sides are. I just made up the 2 to 1. But if I knew what they are, that ratio, whatever they would be, if these are similar figures, would have to be equal to all of the other corresponding side lengths as a ratio. Now, what you do need to be careful about. Number 1, you have to take a side length from one figure and a side length from the other figure. Okay, that's really important. The other thing is that once you establish, what I did is I said, okay, the smaller figure to the larger figure, so the smaller's in the numerator, the bigger's in the denominator. You didn't have to set it up that way, that's just what I did. But if you start by doing smaller to larger, every ratio needs to be smaller to larger. So if I picked another one, AB over GH, that would be the same as if maybe I said BC, and then I would need to take the corresponding side from the other figure, which would be HI. And if I picked another set of corresponding sides, maybe I would do CD, CD2, what would be the other corresponding side? IJ, and then lastly we could do AD and GJ. Now what's nice about these is you don't even necessarily need the picture. The picture's nice, but sometimes what we're going to find is the picture's not like oriented the same, one's like flipped or turned the other way. You really just need the similarity statement. You don't have to have the pictures. I know from the similarity statement alone, A is congruent to G, B is congruent to H, C is congruent to I, D is congruent to J, just because the order. I also know AB corresponds to GH, because they're both the first 2 letters. You see that? And BC corresponds with HI, and you could go on. So the picture is kind of a bonus, but you don't even have to have the picture. Okay? So one of the things you're going to be doing today is setting up the congruent angle relationships and the side length relationships. But then what we're going to do is we're going to use this idea to decide, are these polygons similar? Now, if they are similar, 2 things have to be true. They have to have pairs of congruent angles, which is usually easy to figure out, but they also have to have side lengths that are all proportional. So if I were to look at these 2 figures here, okay, we have these 2 quadrilaterals here. If we look at our side lengths, we just need to make sure I have 4, sorry, not our side lengths, our angle measures. I would need to make sure I have 4 sets of congruent angles. So I know, because it's marked, angle M is congruent to angle W. This is marked that way. Angle J is congruent to angle T, K, and U, because they're both right angles, and then L and V. So I do have 4 sets of congruent angles. But now I would need to check and see if I have 4 sides that are going to be in the same proportion, in the same ratio. So if I were to start, maybe I start with the top to the top, because they are oriented the same, which is nice. So if I do JK, which is 12, okay, one side from one figure, the corresponding side from the other figure. What side corresponds with JK and my other figure? TU, which is 6. Now, what I've set up this time is the larger to the smaller, left to right. Every ratio needs to be set up that way. If I reduce this, I would get 2 to 1. Okay? If these are similar figures, every other ratio needs to simplify down from 2 to 1. So if I take maybe KL, which is 24, what side corresponds with KL? UV, which is 16. But if I reduce this, I get 3 halves, right? Divide out an 8. You get 3 halves, which is not the same. And if you go through all of these, you get 24 over 14. gives you 12 over 7. And then you get, well, this one's 6 over 6, which is 1 to 1. None of them are the same. None of them are. And it wouldn't even matter. Let's say 3 of them were the same and one of them is not. That would be enough to say, nope, not similar. Not similar. Okay, if I look at these two triangles here. Okay, 2 things have to be true. You have to have, since it's triangles, 3 sets of congruent angles. So angle C is congruent to angle F, A to D, B to T. So I've got my angles, okay? On this one, if you guys notice, it's kind of like flipped and turned and all over the place. So the other one, I could just say, okay, the left side to the left side, the top to the top, the right to the right, and then on from there. But this one, it's not. It's kind of flipped around. So when this happens, what I kind of like to do, even though I'm not quite sure if they're similar yet, I think it might be easier to actually write the similarity statement first. So what the similarity statement would look like is you would start with your first figure. It's a triangle, and you can name it however you want. It does not matter how you name the first triangle. So, since it's got an A, B, and a C, I might just name it triangle ABC. You don't have to name it ABC, but I'm going to name it ABC. Now, if I'm going to name this triangle ABC, in the second triangle, if they're similar, okay, the first letter that should come first is the angle that's congruent to angle A. So what letter should come first? D, right? 2 arcs, 2 arcs. The second letter should be the angle that's congruent to angle B, which is E. And then lastly, throw in the F. So if they are similar, this is your similarity statement. Okay? We know the angles are congruent because it's marked, but I need to check the sides. Now, I think it helps to have the similarity statement when you're checking the side lengths, just as a way to double check. Because remember, we don't have to have the picture's nice, to set up the ratios. I know that since AB comes first, AB should correspond with DE. So it's just kind of a nice reminder that AB, which is 12, corresponds with DE, which is 15. So you can see that, right, it's kind of twisted and turned there. Might have taken you an extra second to get that figured out. So my ratio is 12 to 15. If I reduce that, we would get 4 to 5. Okay, and if I set up another ratio, maybe we do BC. What side corresponds with BC? EF, right? The second and third, the second and third. So BC is 16, EF is 20, and 16 over 20 reduces to 4 over 5. Starting to get a little excited here. Yeah? Yeah, okay. All right, and then my last side would be AC, which corresponds to DF. So 8 over 10, which reduces to 4 over 5. Now we're like having a real big party, right? They're all the same. They're all the same. So since the angles are congruent, since all the sides are proportional, yes, they are similar. So if they are similar, the directions, and you're going to have to do this in your homework, it says write the similarity statement, already done, and write the scale factor. That's the 4 over 5. The 4 over 5. Tells you here's how much bigger that other one is than the other one. Okay, then the last thing we're going to be doing today is we're going to be using this idea of similar figures to find some missing side lengths. So they already tell me that I have these two trapezoids, A, B, C, D. The big one is similar to E, F, G, D. Make sure you pay attention. That's the close page that are important to make sure you have it in that order. We want to find the value of x and y. Now we know, since they're similar, the side lengths are all in proportion. So I could set up a proportion. We know how to solve a proportion. We did that on Monday. But if I'm going to set up a proportion, I can only have one missing piece. So when you're setting up a proportion, you need one full ratio. You have to know from this figure to this figure, you have to know one full side of the proportion. So I need to look at my figure and I need to set up a ratio that I know a side length to a corresponding side length. Did I see one?
6 over 9.
6 over 9, right? DE to AD. And we know that they correspond, DE, there it is, to AD. First, third, first and last, first and last. So if I do 6 to 9, I'm the kind of person that I like to work smarter, not harder. So for me, I'm going to reduce this. Don't have to, but they're going to get smaller numbers, so it might be easier. It would be 2 to 3. So the scale factor, now what's important here, the scale factor I set up is from the smaller figure to the larger figure. This is the smaller number over the bigger number. Okay, so it doesn't matter if you do 2 to 3 or 3 to 2. It does not matter as long as you stay consistent on both sides of the proportion. If I use 2 to 3, when I set up the other side of the proportion, I need to take a side length from the smaller trapezoid in the numerator. So what is the side? Y. Okay, let's do Y over what is the corresponding side in the larger trapezoid? 5. Right? Y to 5. Okay, now I have a proportion. How do we solve proportions? Cross multiply, right? Cross products. 2 times 5 is 10. 3 times y is 3y. Divide by 3, and we should get 10 thirds. I had somebody last class that asked if we could turn this to a decimal. You technically can, but it'd be 3.3, and you would probably round. And whenever you round, it's not an exact answer, so for this one, it would be better to leave it as a fraction. Okay, if you don't have to round, if it gives you a terminating decimal, I'm fine with decimals, but if it gives you a repeating decimal, just leave it as a fraction. Okay, now I also need to solve for x. So we're going to go back. We need that scale factor again. We need that 2/3. Remember, we're doing smaller to larger, so I need a ratio using x. What would it look like on the right-hand side? Smaller to larger, x to 7.5. And then we do the same thing. Cross multiply. 2 times 7.5 is 15. 3 times x is 3x. Divide by 3, we should get x equals 5. Okay, this should be glued into page 71. This is section 7.2. Similar polygons. All right, so we're just going to do just a few examples here. So we're going to start. We want to determine whether the polygons are similar. And if they are, we will write the similarity statement and give the scale factor. So number 1. Okay, we're going to keep the drawing simple today. So let's do a right triangle named D, E, F, and then another right triangle named A, B, C. And angle E is going to be congruent to angle B. E congruent to B. DF is 16. DE is 34. FE is 30. AB is 15. BC is 17. AC is 8. Okay, so if they are similar, the first thing, and this is usually an easy one to either eliminate or say, yep, they're good, you have to have 3 pairs, in this case these are triangles, 3 pairs of congruent angles. What angles do you know for certain are congruent? A and F. I know they're congruent. Why? Because they're both right angles. What else? E and B. Why? Because they're marked. Okay, so I have 2 sets of congruent angles. Now, do I know for certain, without a doubt, angles C and D are congruent?
Yes.
Yeah.
Yes.
How do you know they're congruent?
Because all the angles in a triangle equal 180.
Okay. all of the angles here. If you add all of these angles here, you get 180. And you add all the angles here, and you get 180. That's a start.
So take 90 plus whatever on both sides minus.
Excellent. Okay, so if you take 90 plus that angle, which I don't know what it is, right, and to find that one, you would have to get the same thing as if you took 90 and then that same angle, right? So yes, we do have enough information to know that the angles are congruent. Now, like we did on the one on the left-hand side, I think it might be easier when the triangles aren't like side by side, like oriented the same, the left side and the left side. I think it might be easier to write the similarity statement first, even if you aren't sure they're similar. So, if you start with the first triangle, it does not matter how you name the first triangle. Who would like to name the first triangle? Brian.
DEF.
DEF. That sounds like a great name.
That was so good.
DEF. Now, it does not matter how you name the first triangle, but since I named the first triangle DEF, it does matter how I name the second triangle. So, if I name the first triangle DEF, what's the first letter? The second triangle would have to be C. Yes. Angle D is congruent to angle C. Angle E is congruent to B. And then we have our A. So I have my similarity statement already if I need it. But I think this helps set up the side length proportions. Okay? So if I start with DE, DE is 34. And looking at the similarity statement, I know that corresponds with CB, which is 17, which are reduced down to 2/1. Okay, then we could go to maybe EF, which is 30. What side corresponds with EF? BA, which is 15, which is also 2/1. Starting to get a little excited?
Oh, yeah.
Not yet. Not yet. We don't know. There's two sides. What's the last side? We have none.
16 over 8.
16 over
8.
8, which reduces to
1/1.
2/1.
Dude.
Wow. Who knew?
18.
Yeah.
Wow, so like, could you do 17 over 34, 15 over 30, and so forth?
You absolutely could. Yep. As long as you stay consistent. So I just work left to right for consistency purposes, but if you like doing the smaller over the larger, absolutely, as long as you stay consistent. Okay, so 3 things. Yes, they are similar. 2, there's my similarity statement, but 3, I need the scale factor.
Go.
Now, if you were to write it the other way, that's fine. Your scale factor would be 1 to 2, which is the same thing. It's just whenever we grade some more, if you happen to do that, as long as your numbers are the same, no problem there. Okay? All right, and let's just do a couple of the last ones where we're using the idea that they are similar, and we're going to find some missing side lengths here. Okay, so let's draw a parallelogram. And inside the parallelogram
Is another parallelogram.
another parallelogram. Now, for this one, I don't have a similarity statement, so whenever you guys get to your homework, if they don't give you a similarity statement, you're safe to assume that how it appears that they correspond, they do correspond. So that angle to that angle, that angle to that angle, the sides, and on from there. Okay? So let's say we have the top of the small parallelogram is 16, the top of the large parallelogram is 24. The right of the small parallelogram is x, the right of the larger parallelogram is 20. Now, to solve for the missing side length, we need to set up a proportion. And in order to set up a proportion, I have to have a complete ratio. What would be a ratio from, now the big thing here, guys, you have to take a side from one parallelogram to a side from the other parallelogram, one from each. Okay, 16 over 24. Now, kind of like Andrew was asking, you could do 24 over 16 if you wanted to, but if I'm going to do 16 over 24, which is the small parallelogram to the big parallelogram, the entire proportion needs to be small to big. Now, you don't have to reduce this. I think it would be easier just because the numbers are smaller. So if I divide each of these by 8, we get 2 to 3. So my scale factor is 2 to 3, where I have this smaller parallelogram to the larger parallelogram. So what would be the ratio on the right-hand side?
X over 20.
Small to large. Very good. X over 20. And if I do cross products, 2 times 20 is 40. 3 times x is 3x. Divide by 3. And this is 1. I would want to leave it as 40 over 3 because it'd be a repeating decimal, so it's just easier just to leave it as a fraction. Okay, let's do one more. Okay, so I'm going to take you through how to draw this one because it'll be easier then. Okay, so draw this line here, and then draw a bigger parallel line over there. And then connect the sides for some little triangles here. Oh, that's not getting long, not that way. Like that. There we go. Let's try that. Okay, so this bottom angle is congruent to this top angle. This angle is congruent to this angle. And then starting with this left, it's going to be A, B, and 9. And then 15, 10, and 12. Now, they already tell me that these triangles are similar. So, since they tell me they're already similar, I already know that the corresponding angles are congruent. They tell me two of the angles are congruent, but would I know anyway that that third angle is congruent? How? They're vertical angles, right? So, it's not marked that way. They kind of already told me since they're similar, but kind of good to know, okay? Now, be really careful here, okay? Because whenever you're setting up the ratios, remember you have to go with corresponding sides. And sometimes when they're flipped, it's a little hard to tell, and especially when they don't give you the name, so I can't set up those similarity statements. So if I wanted to set up a ratio, I need to set up a ratio of side lengths that I know. So if I were to start here, kind of a way to kind of make your way around the triangle. If I go from the vertical angle to the one arc, this side is going to correspond in the other triangle where it goes from the vertical angle to the one arc. The vertical angle to the one arc. See that there? So that's a ratio I could set up, 9 to 15. And like I said, you don't have to reduce. I think it'd probably be easier if I divide out of 3, we get 3 to 5. So my scale factor is 3 to 5. So if I want to solve for B, what would be the ratio on the right-hand side? B over 10. Excellent. B over 10. Smaller to larger. So multiply up and across, we get 30 equals 5B. Divide by 5, we should get B equals 6. And then to solve for A, we're still using that same ratio, 3 to 5. And what would be the ratio on the right-hand side to solve for A? A over 12. Same thing, multiply up and across. 3 times 12 is 36. 5 times A is 5A. Now for this one, it's probably easiest just to leave it as 36 over 5. But for this one, if you did turn it to a decimal, you get 7.2. If it's 7.2, is that an exact answer? Yes. So in this case, since it's 7.2 exactly, you don't have to round or do anything funky with it. Either one of those answers would be fine there. So if it's an exact answer, decimals are fine. If it's not an exact answer, just leave it as a fraction.